Hello, my name is Dr. Neville Sweijd and I am the Director of the Applied Center for Climate and Earth System Science, also known as ACCESS. Welcome to this online course. It's the second of such courses that we are running. And that is a photograph not of me, but of one of my relatives apparently. And I've included this photograph of the announcement of the new species of Homo naledi for a couple of reasons. One of which is that what is being achieved in South Africa with paleoanthropology is indeed what we also are aiming to achieve with Earth system science in South Africa. And you will learn in this course why Southern Africa is such an important place globally from an Earth system science point of view. But also because this is really a very exciting and significant discovery. I wanted to mark the moment with this image. And not only because it's a specimen of importance that's been found, but also because of the cultural significance of this particular find. So what I'll do in this presentation is tell you a little bit about ACCESS and what we've done, what we've achieved, and what we're planning to do in the near future. This photograph was taken of one group of our postgraduate students. We have about 150 students that have passed through or will have passed through the system in ACCESS over the last few years. We have an annual meeting of our postgraduate students in order to create a fraternity among our emerging scientists in the country. This photograph is taken at the University of the Western Cape. So ACCESS is a consortium of a number of research organizations, some research agencies such as the CSIR, South African Weather Service, the Southern African Institute of Aquatic Biodiversity, SANBI, and others, as well as many universities across the country. We also have connections with the continent, not only by virtue of the African students that are studying here in South Africa in our program, but also activities that we've run in Kenya, in Namibia, and Ghana, and connections with other processes in Africa as well. So the important point here is that we're a consortium of different organizations. Now, currently ACCESS is an instrument of what is known as the Global Change Grant Challenge, which is a program run in the Department of Science and Technology, part of the strategy of the department, the long-term strategy of the department. And we also, up until this year, are operating as a center of excellence among the several centers of excellence that exist in the country. This is an instrument for research implementation in the country. As I'll tell you later, we're going to be changing that arrangement in the next few years. Now, the Global Change Grant Challenge has a number of entities, a number of different programs, including the Risk and Vulnerability Atlas, Global Change Program, the new Space Agency of South Africa, and includes SAON and AON and a number of other structures. And together, this arrangement of different entities is implementing the Global Change Grant Challenge, which focuses our stress on global change, which is really looking at a whole range of different agents of change in our environment and in our society, which includes, of course, climate change. So climate change is one of the drivers of change in our society, again, something which you will explore during the execution of this course. Our science is based on the Global Change Research Plan, which is a plan that extends across this particular cartoon, as you'll see it here. From the left-hand side, looking at the planet as a functioning Earth system, or system of systems, looking at human impact on that system and the system's impact on humans, adapting the way we live, and looking at innovation for sustainability. Our center of gravity is really on the left-hand side, looking at the Earth system science aspects of global change and interaction with society. But the work that we do does span right across this whole ambit, from Earth systems right through to development of new applications, for example. One of the other important aspects of the program is our capacity development element. And in red there, I've circled this concept of the extension of research capacity. And this is an important concept. We often talk about capacity building, but in this program, we do more than just develop new skills or assist in the development of new capacity, but also look to extend our capacity. And by extension here, we're referring to the inclusion of a range of players, of institutions and areas of our country which in the past did not participate fully in research and innovation in the country, and that's one of our goals. If you want to learn more about the Access program, then you go to our website and you'll find a whole lot of documents which look at our original plans, some of the reports, annual reports, the research compendium, which tells you all about the specific research projects that we're involved in, and some research highlights publications. So part of the program is our education and training sub-program, and we have a whole range of different activities, a very vibrant and active education and training program. I've mentioned our postgraduate students. What I just want to quickly go over is that we try and connect up the different elements of our research and of our education and training portfolio. So we have the mainstream impact in research is indeed our postgraduate students. This is generally true. They are really agents of research, and that's a big focus of our work. But we also try to work with undergraduate students, and this is what the Habitable Planet program is. We focus on undergraduate students because we want to draw students into research careers, and particularly students from backgrounds where the tradition of doing research might not be that common. And so we focus heavily on trying to recruit students from that pool of potential postgraduates. And then beyond that, we go into our schools program, where some of the Habitable Planet students have in fact developed schools programs which they execute themselves. And then going up a bit, we've been active in the area of emerging researchers, postgraduate students, if you like. Those are young scientists operating in various agencies and research institutions. So that's the sort of scope of our project, and here's some images of our master students meeting school students, photograph of one of the Habitable Planet courses, some students that were participating in our statistics and modeling training course some years ago, and an early career workshop which we've held in the past. Access has been a very active program. I've said we have, by the end of this year, we will have put through about 150 postgraduates through the program, and you can see the breakdown of some of the statistics, and we've been very productive in producing a number of research papers as one measure of our outcomes and our productivity. Now, what I will talk about briefly is the new phase of the Access program, which is going to commence next year and will last for 5 years. So we've completed the first phase, which was really the establishment phase of the program, and now we're going to move into a more focused phase of research and our education and training activities. So what I want to talk about is the concept around which we are building our research focus for the next part of the program, the phase 2 of the program, and use this example of the seasons as a focus of this thinking. So what you're looking at here is an oscillating signal. We can regard this as a seasonal signal of some kind or another. It can be temperature, it can be rainfall, depending on where you are in the country. Of course, these seasons are not the same, even within South Africa. So we'll have a winter and a summer. So if you consider the top part of the curve being a summer signal and the bottom being a winter signal, we'll see these signals vary. So in the north of the country, for example, we have summer rainfall, so rainfall peaks in summer, and there's a drought season in the winter. For the Western Cape, for example, it's the opposite. We have a drought in the summer, and we have our wet season in the winter months. So normally we see this oscillation. The red lines, the solid red line at the top, really represents the kind of variation in our seasons that we are used to. Now, this is a very idealized example that I'm showing you here. It's not something which is really true to life, because in life we will see much more noise in this regular signal. But nevertheless, we are used to the kinds of summers, the kinds of winters that we have grown up with and our society has developed in. We know that in the Southern African region, in particular our country, relative to other parts of the world, our seasons are very mild. We get a little bit colder in winter, sometimes it freezes, and it gets quite hot in the summertime. So winter is cold, summer is hot, and as we've spoken really about rainfall varying in different parts of the country. So we're used to it. We don't have central heating in this country, for example. It doesn't really get cold enough to justify it, although I know that some houses in the north of the country do have central heating for the winter months. We know that we use more electricity in winter than in summer because we needed to keep warmer. We know, for example, when it gets windy in the Western Cape or when it's rainy in the Western Cape. And our society is adapted to living within these normal ranges. And this is an important element of global change, to understand how our society is adapted to what we are used to and how our society has developed. The dotted lines there represent those people in our society who have an economic disadvantage. And for them, coping with even what we might term as normal climate variability from winter to summer or seasonal change is challenging. So if you don't have central heating and it's very cold, you have to make other plans, or you have to suffer the consequences of what we can term normal climate variability. So if it's very wet, you suffer because there's flooding and there's not proper drainage. Your children might get ill in the winter, for example, and so on and so forth. So this differential between the solid and the dotted line represent this change, or this ability to cope, this range of adaptation to even normal climate variability that is experienced by virtue of the inequities and the inequality in society. And again, this is an aspect of global change which we have to understand as we become a bit clearer. So this is what I would call normal variability. As again, I emphasize this as an idealized version of what it looks like. Now, society depends on our seasons. If we think about that, we've learned and evolved to cope with these biggest of all signals, these seasonal changes that I've just explained. And as I've said, the ability to cope varies socio-economically. If you think about it, all sectors of our society are really geared to operate in seasonal mode. I'll give you a trivial example. When do we have summer sales? When do we have winter sales? For example, when the season's clothes are sold out and they want to put in new stock for the next season, summer clothes, they'll sell off the winter clothes. So in retail, as an example, we see this. But in fact, in other sectors of our society, such as agriculture, in mining, in energy supply, in tourism, in transport and health, all of these aspects or elements or sectors of our society are indeed adapted to seasonal climate and how they operate and plan for different seasons and prepare for different seasons. This is true for government services such as disaster risk management, in health services, for example, and it's also true for ecosystems and ecosystem services. So when do animals breed, when do we plant, and a whole variety of different processes in the natural world also depend entirely on seasonal signals. So in fact, we are very well adapted to this normal variability. However, this normal variability is not generally consistent, as I've already said. So if we look at the top graph here, first of all, variation in the signal does occur. So it's not a steady signal. And those little blue triangles above the red line or below the red line in the top graph, those represent what we might call an extreme event. And we have extreme events. You know that you might be familiar with droughts, which are extended periods of no rain beyond the seasonal expectation. We might have floods when it rains excessively, and we have too much precipitation or other causes of that. We might have storms which are extraordinary. We do expect storms in certain seasons, summer in the north, winter in the south, but those storms can be quite extreme events, sometimes very unusual. Sometimes we have a 1 in 50-year storm, or a 1 in 100-year storm, or even a 1 in 1,000-year storm, which are very extreme events. And when extreme events happen, then that seasonal signal, or that signal that we're talking about, extends beyond what we are adapted to. And then we see damage happening. We see loss of life, we see the destruction of infrastructure, and a variety of other ill effects of these extreme events. And if you have that economic disadvantage, then your ability to cope with those extreme events then also is impacted more severely, because you don't have the resources to recover as quickly or to adapt. So if it gets really stormy and cold, you might dress up warmly and get tucked in your bed, have some hot chocolate, put on the heater. But if you don't have any of those resources, you can't really adapt to those extreme events, as one example. Now, it's argued, of course, that with climate change and into the future, some of these extreme events might happen more frequently, or they might happen more intensely, or they might happen for more prolonged periods. And so, in order to understand the impact of climate and on global change, and global change on climate, in fact, we have to understand what's trending. How are these seasons trending? What's happening to our summers? Are our summers getting warmer on the whole, if you compare one summer to the next? Or is winter getting colder? Is it getting more rainy, more windy, more dry in different parts of the country? And so one of the important elements of climate science is to understand what's happening with these signals in our climate system. It's useful to look at averages over the year, the average temperature over the year, but it doesn't tell us a lot about how things are changing at the scale, both time and space, that we might need to appreciate it. So this is really important to understand. And then, of course, our impact on climate change, our impact on the short term, in climate variability on the short term, on these extreme events, and on the long term. And then, of course, we have to consider other drivers of change. And I'll give you an example of that in the lower graph. In the lower graph, here you see the same effect, but in this case, you'll see, of course, that the red lines are not parallel anymore. And over time, we see that our ability to cope, our tolerance threshold, is reducing. And this is largely a consideration of global change. So, for example, if we are damming rivers, or we are canalizing rivers, or our population is becoming more urbanized and there's more informal settlement, or we're changing the way in which we manage land, for example, all of these then impact on our ability to cope with extreme events and these changes. So not only is the external signal of climate varying and changing over time, as it always has in the past, but also, and very importantly, our ability to cope with that is also reducing. So that's a combined effort of a whole variety of changes to our environment and to the system in which we live, and the changing external forces. And it's important to understand this, that climate as we know it has, of course, not always been this way. If we had come to this planet 3 million years ago or 10 million years ago, we might not recognize this as planet Earth. The configuration of the planet, of the continents, the types of climates that we might experience in the different parts of the country and the world which we are familiar with might have been very, very different depending on what stage in the geological past you are considering. So we have to understand that climate always changes, and always has changed and always will change. It's really about how our society as we know it in the recent history of this planet has developed and has adapted and is managing and interacting with the environment. And those are the considerations we are looking at. So this idea of understanding things with the lens of a seasonal cycle is really important for us, and this is what we're going to be concentrating on and designing our new science plan around for the second phase of the program. So just to summarize, what's happening with Access is we've come through this phase where we've done a lot of research on a variety of different elements of global change, and we have now decided to focus in on the seasons in the future. The institutional arrangements of the program will probably also change, and the program will now move closer to the center of research operations in the country in the National Research Foundation. But we will continue to grow our program both in terms of the research and in terms of the education and training program that we have been operating. And this is just to point out that there's a tremendous amount of infrastructural investment happening in this country in terms of the SANREN network, the Center for High Performance Computing, the new GALAS, the SKA. So a tremendous amount of opportunity that we have in South Africa, which we are very privileged to have access to. And we have a number of international partners. For example, Access is running a program with some German colleagues and with some Japanese colleagues looking at the impact of climate and climate variability and global change on biodiversity, on agriculture, and on health. And so with these many partners and with the participation of our local partners and you, the students who are involved in research, there's really a great opportunity that awaits you, and we hope that this course will inspire you to take up that opportunity, get involved in the most fascinating set of research questions, some of which I've just mentioned and the rest of which you are going to encounter in the rest of this course. The course is very exciting, it's very broad, but yet it is hopefully a very inspiring experience for you, and we hope that you will succeed in completing the course and will join us not only in celebrating what we have to celebrate in terms of Earth system science in Southern Africa, but also will consider following this up with a career in research. So I wish you luck, I hope you enjoy it, and we will see you again very shortly. Thank you.